Hello, I am Kiran Kumar from Nature of Physics. Today topic is potentiometer LAQ from the current electricity. We will have two questions. First one is comparison of EMF by using potentiometer. Second one is determination of internal resistance by using potentiometer. Now first one I am doing. Second one video link I will provide in the description. Okay. First one is comparison of EMF by using potentiometer. Okay students. See now potentiometer definition, derivation, proof I will give to you. After that, comparison of EMF by using two cells in the secondary circuit we will discuss step by step. Okay, and first I am considering definition for the potentiometer. The potential difference across the any part of the uniform wire is directly proportional to the length of the third portion when constant current is flowing in the wire. Student, okay, what are the conditions are there? Potential difference across the any part of the uniform wire is directly proportional to the length of that portion, and condition is uniform current passing through that wire. Okay student, so that the potential difference is V is directly proportional to the L, so V which is equal to phi L, so where phi represent potential drop per unit length. Okay, so using the Ohm's law, V is equal to IR, so proportionality constant is phi written student there. V directly proportional to L because of potential difference across the any part of the uniform wire is directly proportional to the length of the wire. And next discussing about the Ohm's law proof for the potentiometer. See student, Ohm's law, V is equal to IR. So that here R is the resistance, R value I am replacing, R is equal to rho L divided by A. Then the equation is V which is equal to I into rho L divided by A. Okay student, and then continuation step here, V which is equal to rho L rho I divided by A into L writing student, so that I can write here V which is equal to phi into L student. So this is the proof for the potentiometer. Potential difference is directly proportional to the length of the any part of the uniform wire. So this is I am writing as equation number 1 student, and continuation there, phi represent potential drop per unit length, and phi value also we can write here, that is phi which is equal to I rho divided by A student, I rho divided by A. See, phi replacing I rho divided by A. Okay student, and then continuation, next I am going to discuss comparison of EMF of two cells by using potentiometer. Okay, so E1 and E2 represent the EMF of two cells. Okay, the primary circuit consists of battery B. See, this is the battery B, and rheostat or H, and key. This is key like a on off button. So now this according to the diagram, key is closed. Okay student, these are in series combination, battery, rheostat, key. So this is primary circuit. In the primary circuit, battery, rheostat, key in series combination. Okay student, and then secondary circuit we are discussing. This right side portion represent the secondary circuit, and across the AC, that is representing a length of the potentiometer wire, that should be nearly 10 meters student. Okay, so that is arranged like this according to the diagram. Okay, and at A is connected to the secondary circuit by two cells of EMF. First one is E1 student, and second one is E2. Okay na, first cell of EMF E1, second cell of EMF E2, and here this is the positive terminal, negative terminal, this is positive and this is negative. Positive terminals are connecting to the primary circuit, and negative terminals are connected to the key student. Okay, and key to the galvanometer to the jockey is connected. Okay, so the secondary circuit of two cells, positive terminals connected to the primary circuit clearly represented, and negative terminals also connected to the key. This is the key in the secondary circuit. SC represent the secondary circuit, and also galvanometer and jockey connected, so that key galvanometer also in series combination with respect to jockey. Student, I will draw the jockey. Okay, so that, wait a second. So first representing like this, student. Okay, now see, this is J represent the jockey, student. J represent the jockey, and here first null point we are getting, that is equal to N1. Okay, we will discuss that. Okay, so jockey can move from the position A position to C along the length of the potentiometer wire. So the position of the jockey is adjusted on the potentiometer wire. The position of the jockey is adjusted on the potentiometer wire from A position to C position. Clearly written, student. And continuation, now conditions we have: key is connected to a cell of EMF E in the secondary circuit. We can take capital E or small e letter, student. Anything is remain same only in the secondary circuit, clearly mentioned there. Okay, and the position of the jockey is adjusted on the potentiometer wire, and balancing point is obtained is L1. Okay, student, see, notice the difference here. I'm considering the length is AN1 is equal to L1, student. AN1. Okay, this point to this point N1. See, like this. This length is taken as L1 length is balancing length, student. Okay, and see, the position of jockey is adjusted on the potentiometer wire from A position to C position. Balancing point is obtained in the galvanometer. Galvanometer show the zero deflection while moving the jockey from A position to C position at particular condition N1 position with respect to jockey. Okay, student, now this is the closed circuit. So I have to connect here. This key is connecting to the second circuit for this second one. Okay, so first one already completed, student. So derivation I will give to you. Already we have idea the potentiometer. Okay, the potential difference is directly proportional to the length of the wire, student. So for this condition I'm going to write here. So cell of EMF E1 we are considering, and second one is E2 considering. Anything same only, so that E directly proportional to the L, student. So E1 first cell connected directly proportional to the length is L1, so that I can write E1 which is equal to phi L1, student. This is I can write as equation number 2. See, student, so E1 which is equal to phi L1. Phi is the potential drop per unit length, is a proportionality constant. Okay, and then continuation same we will discuss for the second one also. So key is connected to the cell of EMF E2. So E2 already connected, student. Okay, so first connected to the cell to the E1. Okay, second connected to the cell E2, student. Okay, so that key is connected to the cell E2. So E2 connected now. See there, clearly represented. The position of the jockey is adjusted on the potentiometer wire. Same situation, moving from A position to C position. Okay, and balancing point is obtained at a length L2. See, student, I am going to draw the balancing point. See there, like this I can represent the balancing point. See, student. Okay, now so now I can represent this is jockey, student, and null point position is N2, students. See clearly from the position A to this position, null point position N2, that balancing length is taken as, what is that, student? That is equal to L2. Since I can write here clearly, that is A and 2, which is equal to L2, student. Okay na? So that same situation, the potential difference across the any part of the wire is directly proportional to the length of the wire from the potentiometer formula. So that here cell we are considering, that cell EMF is E2 is also directly proportional to the L2, student. And then continuation E2, which is equal to phi L2, this I can write as equation number 3, student. And continuation step, that is equation 2 divided by equation 3. So that equation 2 divided by equation 3, and E1 divided by E2, which is equal to phi L1 divided by phi L2. Okay, student. And then continuation step there, phi is get cancelled there. Then I got the answer E1 by E2, which is equal to L1 by L2, or we can write E1 by E2, which is equal to L1 by L2. So this is the answer for the given question. So simply given, everything clearly written. So sequence, continuity, diagram perfectly step by step we did, student. Okay, so simple basic formula, potential difference across the any part of the wire is directly proportional to the length when current is equal to constant in a wire. So proof also I gave you, student. So that phi is equal to potential drop per unit length. So potential difference, which is equal to phi into L, I got is equation number 1. Okay, and primary circuit is there, secondary circuit is there. Primary circuit, battery, rheostat, key in the series combination. In secondary circuit, okay, so here cell, any one of the cell only we can connect, student. Cell, galvanometer, jockey also in the series combination, including key. So first key is connected to the C, student, J1. Okay, so key is connecting to the cell of EMF E1, student, first, and second is connected to the cell of EMF E2. So for first one I got the equation E is equal to phi L1, and second one connection I got the equation E2, which is equal to phi L2, student. Equation 2 by 3 we got the relation, that comparison of EMF, that is ratio of EMF of two cells by using potentiometer. Okay, please do like and subscribe our channel Nature of Physics.